Okay. Okay. I just want to make sure it's recorded. Okay. All right. Okay. Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. Uh, in today's topic, we are going to talk about analysis models and algorithm used in robotics in automation. This is a continuation of the uh, previous lecture on robotics in automation. Okay, uh, you can refer uh, the lecture in the lecture video in the previous uh, videos lah. Okay. Okay, so this lecture today, I'm going to cover about many analysis methods such as coverage pattern analysis, uh, okay, coverage pattern analysis and time measurement analysis, and many more. Okay, so there will be 23 slides. Okay, that I will cover. This I will first cover on coverage pattern analysis, and then I will proceed on the algorithm, and then the models and everything. All are related to the robotics in automation. So the idea is you will get some idea all these latest research on all these methods that are being used, all these methods, all these models, all these algorithms that being used in research on robotics and automation. Okay, uh, the way I choose it, I I analyze using the software that I created, analyze all these methods, analysis algorithms and everything, and I find out these are the most used analysis models, algorithms in robotics in automation. Okay, so this is I will share to you. I will explain to you what is the meaning of that and that methodology, and then how they are used in the research, so that you can get some idea when you encounter this kind of problem, you will know that there are analysis uh, that can overcome your problem. Okay, so we start with coverage pattern analysis. Okay, so coverage pattern analysis, uh, they revolutionize how robots navigate and cover spaces. In simple terms, CPA ensures that robot cover every inch of a designated area in most efficient way possible, avoiding unnecessary repetition, and delivering tasks like cleaning, surveying, and monitoring are done thoroughly and swiftly. Okay, this concept become more crucial in complex environments such as indoor spaces where obstacles and layout intricacies pose significant challenges. A groundbreaking aspect of modern CPA is its synergy with building information modeling. By integrating building information modeling, which provides detailed 3D model of building with coverage pattern analysis, robot can navigate and cover indoor spaces with unprecedented accuracy and efficiency. This integration allows for creation of semantic trapezoidal grid maps, a method that segments spaces in a way that significantly simplifies navigation and coverage tasks. Okay, researchers such as Zhang et al. And Li et al. In 2024 have pushed boundaries for CPA. Okay, they introduce innovative concept like coverage bonus and algorithm tailored for optimizing coverage sequence, significantly enhancing the performance of robots in construction and facility. Okay, so there are research by this person. There are researchers like Li and Liu and Zhang, and so go towards CPA enhancement through building information model. Okay, there are another term. It's called bidding information modeling. When architect want to design the building, they have the library of information of the architect. Information that you can imagine like when you are doing technical drawing, you have the library, and when this library, you can drag, cut and paste and everything to help you to design the thing that you want. The same goes for the architecture. They have the building information modeling. So this information they can use to lay out the of the building. So the robotic, okay, the robot when they move, they integrate with the information with the building information modeling, and then they can move swiftly lah, because the robot will know where is the door, where is the obstacle, where is the wall and everything. So they can move. Okay, this this is called coverage pattern analysis. Okay, so let's go. Like this is illustrated for the I just generate picture using ChatGPT to make it available for you lah. Kan? Okay. So time measurement analysis. Okay, the second one is time measurement analysis. Okay, represent the evolution of manufacturing efficiency, particularly in realm of robotic automation, in measuring how long tasks take in manufacturing process, aiming to uncover and eliminate time wastage. Of course, this is what you learn in lean manufacturing. You don't want waste. You want to productivity of the time. Okay, so aiming to this is a process of fine tuning watch to ensure it's quick keep time perfectly. So only way tuning robotic system and operate to their best. Okay, recent study by Kim Choi and in 2024. They integrate time measurement analysis with digital twins, which is digital twin is a virtual replica of the physical system to optimize the performance of autonomous collaborative robot. Integration allow for the simulation and fine-tuning of robotic in virtual environment before their real-world application. Okay, meaning that before the robot operate, it is being simulated in the system with digital twin, with help of digital twin to make the movement more time efficient. Okay, so we can dissect or each movement and process is simulated system, pinpointing efficiencies with precision. Okay, there are software related to it lah. So okay, like method and tool used in time measurement analysis, they use the time measurement, okay, MTM and Maynard operation sequence technique most within the twin for accurate efficiency evaluation. Okay, so okay. Before the robot operate, the robot can identify which things that takes with operation that takes the most time, and they want to reduce the time to movement, time to do the operation and everything lah. Okay, so this is called time measurement analysis. Okay, okay, this is an illustrative picture of it. Okay, and then image processing algorithm. Okay, you have I'm sure you have heard of this before. Okay, it is a popular method in robotics, in also machine vision. They have done it many years ago. Okay, image processing algorithm analyze digital images to enhance, recognize pattern and extract information for advancing robotic autonomy and versatility. Okay, there are research by Carvajal in 2024 and Evic et al. In 2024 demonstrates image processing algorithm role in aerial manipulators and UAVs for tasks like object recognition and structural inspection. Okay, highlighting the shift towards autonomous operation. Okay, so algorithm flexibility and adaptation. Okay, their study shows that IPA adaptivity in dynamic condition such as lighting movement, enhancing robot efficiency and adaptivity to through optimized perception system. Okay, so they are using UAV and unmanned aerial vehicle. Okay, because nowadays you can see UAV have been used in many application in some use UAB, others use the word drone and everything. Okay, because uh, they can fly, and then they can identify all this information and relay the information to us, kan, to the operator. Okay, so some of the information is being processed by AI and machine learning integration, use convolutional neural network for image analysis. Okay, and offering precision and expanding application in non-destructive testing. So see another note, I think uh, some can identify and detect damages in cracks in imagine when before UAV, before UAV or drone coming into the picture, people have to rent the crane, okay, to go to the high-rise building and to see with their own eyes where is the crack and everything. Of course, a human will tend to go for error, meaning that they may have fatigue and everything. They are not aware of some cracks. Okay, so robot can help people, can help the operator to identify all these cracks and everything lah. Identify where is the damages on the structure and everything. So this will be help with image processing algorithm. When we give the information to the system, they can identify which is the crack, which is not a crack. Which is the things that damage is which are not things are not damaged. Okay, so this is an illustrated picture of it. So bee colony algorithm. Okay, there is a bee colony algorithm. So what is a bee colony algorithm? Inspired by natural foraging patterns of bees, which have emerged powerful tool in automation industry. Okay, this algorithm mimic how bees communicate and optimize their path to best food resource, applying this strategy to solve complex automation challenges such as task allocation and scheduling. Okay, so how does the bee does the bee locate their food? Okay, people inspire, scientists inspired by the way that the bees uh, uh, locate their food. Okay, the bees travel. The bees come out from their hive, and every day they come out from their hives. They want to find the uh, the 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 honey lah, kan, from the honey and everything. Okay, and when they find the good source of honey, they give the signal to their friend. Okay, stop doing everything. Come to him. Come to me. Come. They come to me. Okay, meaning that one bee, they one bee find a flower that have honey, and they just give the signal to every other honey to stop their work. Okay, come to me. We, I already found the place that we have a lot of honey. So stop your work and come to me. So they come to that bee, and that bee and they forage all the honey lah. Yeah. Okay. Okay, so this is how the bee colony algorithm works. Okay, inspired by foraging behavior of honeybees. Okay, to optimize task allocation, scheduling, and decision making. Okay, application in agriculture and manufacturing demonstrated by Ba Chang, Liu Wong, and Dong in 2024. This algorithm significantly improved the efficiency in smart farm and manufacturing workshop. Okay, so, adaptability of bee colony algorithm to dynamically adapt and to environmental change and optimize operational efficiency, overcoming local optimums and enhancing global search capabilities. Okay, evidence of superior performance of this algorithm in complex task allocation and scheduling issues, performing other meta-heuristics algorithm like simulated annealing and quantum artificial bee colony. Okay, so broad application and future potential is beyond agriculture. Uh, this bee colony algorithm can be used in many application lah, kan? Okay. So, meaning like the finding potential sources of source of people, maybe finding people that missing and everything lah. Okay. So this is an illustrative of it. Okay. And then they come the interactive coupling algorithm. Okay. It is a cutting edge approach in robotics focused on dynamic interaction within automated system to improve predictive accuracy and operational efficiency. Okay. It is demonstrated by Chinterm et al. In 2024 and Zaga in 2024. This algorithm optimized milling stability efficiency by integrating structural dynamics and cutting force model. Okay. So this is also can be defined by as automation also, but it focus on a single machine. That is the cutting machine. Okay. Uh, you remember when you learn about CNC machining, or any other machine, okay, any other machining like lathe and everything, okay, when we cutting, okay, there are two major operation that involve simultaneously, which is the structural integrity of the cutting machine itself, okay, and the cutting model, okay, and the cutting force. Okay. So at one side, we want the machine to be stable enough to withstand the vibration of the operating condition. Meaning that when we are doing milling, okay, the mounting of the machine must be good enough so that it doesn't affect the cutting of that the cutting quality. Secondly is we want to make sure the cutting force is good, not unstable. Okay, so these two, they have an algorithm by its own. One algorithm for the stability and one algorithm for the cutting force. So how about we integrate both algorithm? Okay. Okay. This is applied for the research by Chintam and all and Zaga. They integrate both algorithm lah. Okay. So how about for other application? Okay. So that we can integrate many algorithms so that we can get optimization on then our purposes lah. Not only limited to the cutting force on the CNC machine, on the CNC robotic and milling, and we can do for many other operation as well. Okay, this is called interactive coupling algorithm. So it is illustrated by this machine, this picture lah. Okay, action recognition algorithm. So it enable robot to interpret human action with high precision, thereby enhancing efficiency and safety in manufacturing in assembly line. So the integration of such algorithm into digital switch system explored by Tarantus and all provide seamless interface of robust human robot interaction. Even okay. So by employing techniques such as human mesh recovery and personalized federated learning, researchers like Zhao et al. Okay. They use the real-time action recognition. Okay, this algorithm overcome limitation posed by occlusions, and but also bring a control level of risk to the recognition process, making human-robot interaction more relevant and effective. So we see the thing is the robot itself, they interpret what we do. Okay, and okay, they use the digital twin system and personalized federated learning method for enhanced human robot collaboration. Okay, I think you can read this. Key focus on developing robots algorithm for reduction, accurate human bodies, integrated uncertainty estimation to manage risk in recognition process. Okay. the robot learn what we do lah. Okay. So this is an illustration of it. Exposure entropy prediction model. Okay. And it enhances robotic vision by optimizing exposure time for highly quality image capture, crucial in automation tasks under challenging lighting condition. Okay. So what we can easily to understand is when we operate, we have lighting. Okay. Sometimes lighting is low lighting, means a little bit dark. Sometimes it's more lighting, like we want to do our operation in an open and hot afternoon. Okay. So the lighting is over. Okay. How then we are talking about the quality. Okay. uh, this we want to mimic human eye. Okay. Because human eye can adapt to all the situation. Okay. How about robot? We have to learn. Robot have to learn. Okay. So what scientists do is they expose the task a little bit longer. Okay. So that the robot can identify, okay, this operation is done in a little bit dark environment. How can the robot do? And then another condition, the robot operates in highly lighting, like in the hot afternoon. Okay. Outside. Okay. Outside your factory. Okay. How can the robot operate with all the such over lighting? Okay. By the sun. Okay. So this is what exposure entropy prediction model happen lah. Kan? Integrates ROI extraction. What is ROI? Okay. Quality assessment and exposure time prediction module using image entropy as a key metric for adjusting camera setting in real time. Proof effective in aviation, drilling, and robotic disassembly. The model employs predictive learning uh, to ensure the capture of optimal images. Okay. Researchers like Lu, Jiang, and Yi, and Chen et al. Has contributed into refining this model. Okay. Uh, they use seamless integration of module design to extracting region of interest, assessing image quality based on entropy, and predicting optimal exposure time. The model facilitates a dynamic adjustment of camera setting. The adaptability ensures that robot equipped with this mission system can operate efficiently. Okay, even with narrow while lighting condition may otherwise impede performance. Okay. Uh, so this is the illustrative picture of it. Okay. Now we're talking about deep learning model. Okay. Okay, deep learning model. Uh, uh, okay. I want to take the note yet. Okay. Okay. Integration of deep learning model in robotic, driving advancement in perception, interaction, and decision making. Application in across domain, personalized home care. There are many things, but the definition of deep learning model have been told to you in the last class. Okay. That there are layers of basically there are layers of more learning. Okay. And then the robot analyze and everything, and then uh, they this is called the deep learning model lah. Not only the surface model, but the robot thinks like a human. Okay. So there are many application of it in healthcare, in factories, in decision making and everything lah. Okay. And then the structural dynamic model. Okay. Offering for insight in optimizing robotic performance in milling in construction automation. This model address critical challenges, especially with issue of low stiffness in robotic arm, which can lead to chatter, vibration, affecting machining quality and overall. Okay. So the work by Chinterm et al. In 2024 represents significant leap. Its algorithm merge lightweight structural dynamic model with interpolation algorithm enabling accurate vibration prediction for robotic milling. Okay. This model can predict instability issue like chattering, vibration, regression, and also enhance simulation speed, facilitating more robotic operation. Okay. So research by Zaga et al. Okay, integrating elastic properties into dynamic model for better stability lah. Kan? So model. What the robotic arm, okay, the robotic arm is thin tau. Like we can imagine our hand, okay, compared to the our hand, okay. Imagine you and your friend which is a bodybuilder, okay. Your friend always uh, do the bodybuilding, lifting all the weights and everything. Of course, his hand becomes stronger than you. Okay. So when his hand becomes stronger, okay, his hand become big and bulky. So his hand is more stable in lifting heavy objects and everything. Whereas you don't do that exercise that much. When you are lifting heavy load, you become your hand will become vibrate. Chatter, this is called chatter. The same goes to the robot. Okay. When the robotic arm, okay, you can imagine the robotic arm, they have a thin cantilever. Okay. This thin cantilever is tendency to become vibrate. And when it become vibrate, it will affect the quality of the cutting force, milling and operation, everything. Okay, so because the robotic arm will do the milling process, everything. Okay, so to overcome this problem, there are two researchers, which is Chintam and Zaga. They predict the vibration, and then the algorithm, the model will overcome that vibration to happen. So that the thin cantilever can operate in to cutting. Whereas if not using this model, this thin cantilever will become vibrate more. It become vibrate more, and then the quality is not that good lah. Kan? The cutting quality is not that good. Okay, so this is the called structural dynamic model. Okay. Okay, robot stiffness model. Okay, robot stiffness resistant to deformation under load is crucial for accuracy in high precision tasks like robot forming of ultra high strength material. Okay, challenges in robot forming, stiffness deformation poses significant challenge affecting machining quality and efficiency, particularly in forming compact thin welded profile. Okay, so they use the iterative path compensation. Innovative iterative path compensation method has been proposed to mitigate the adverse effect of stiffness deformation. Okay. Some researchers, okay, it's not mention name of researchers, but imagine when we are doing this robot, okay, the robot um, operate by doing the forming process. They press, okay, the pressing process, everything. Okay, when we press something, the significant load is high now, and when it's high, the robot tend to deform. Okay, how can we overcome this deformation? Okay, there are iterative path compensation method, meaning that when the robot doing the pressing, it will go up and down a bit, little bit until we get the desired shape. Okay, if the robot press too hard, maybe the robot will damage, kan? maybe the robot with the image, maybe the effect, the quality effect. So this is what the robot stiffness model come in handy lah. Yeah. Okay. And then the last one is the cutting force model. What is the cutting force model? It is also related to automation, okay, but it involves only one machine, okay, which is the machine on cutting, milling process and everything lah. So we it is an important role in robotic milling and machining, aiming to enhance precision and efficiency by accurately predicting the forces exerted during machining process. Okay, so we learn from our degree days, okay, that when we are cutting, there will be cutting force. Okay, when it is more cutting force, okay, there will be welcome vibration. Okay, this vibration is this vibration of thing it can make the unstable and not accurate high quality of the surface. Okay, so uh, research by Chintam and Zaga uh, uses the iterative coupling algorithm, that one that I just discussed to you in the previous slides. Okay, this model will be combined with a coupling structural dynamic algorithm, so that it will come compensate which one we want to get high quality surface, and then this will overcome all the problem of the cutting model and structural integrity and everything lah, kan. Okay, so that's all for our slide today. So I hope you can learn something lah. Okay, to learn better you download my book, that which is I already provide to you in the Google Classroom, so that you can read. Okay, so that you can read, you can learn what is the what is I talk about in this video lah. Okay, so that's all for now. Wish you the best. Okay, thank you very much. Okay, Assalamualaikum and a very good day to you all.